Good evening, everybody. Uh, Welcome, a very warm welcome. I don't know how it is where you are, but it's not very warm here in Durban. So I bid you a welcome to this third session of the Junior Olympiad training program. And once again, I want to express my gratitude to all of you and also my congratulations that you have qualified to enter into this program. Not everybody is privileged to be in this program. A special word of welcome to my colleague from the South African Maths Foundation, Khotso, who will be helping us. And I also want to bid welcome to some names that I can recognize here. My good friend, Dr. Benjamin Tatira, welcome. He is one of our center managers. And I thought I saw some other names I recognize. So if you are a tutor or Dr. Mpofu, welcome, sir. So we are very happy to see some of the center managers as well as some of the tutors. All right, so today, there's one announcement I have to make before I start, and that's for the benefit of my friend Khotso from the South African Maths Foundation. Please, when he sends a link at the end of the program, don't go away. Click onto the link and mark yourself present, because we are taking a register at every one of these sessions. So please mark yourself present. I will make this announcement again for the benefit of those who are coming in late. All right, so with that, we can start our session. Today we are going to do some interesting problems. These are problems which usually give learners and teachers quite a challenge, because they are problems which we call distant time problems. So I'm sure you're going to learn quite a bit, because we are going to do quite a few of these problems. Some of them are quite challenging, but we will get there. All right, so let's go to the first problem. Before we start, I want to say some rather important things here. And we want to analyze what you mean by speed. Now, if you speak about speed and if you say, well, the car is traveling at a certain speed, you normally say it's traveling at so many kilometers per hour, which you write like this. Okay? What is the meaning of this? The meaning of this is that if you are saying so many kilometers per hour, say, let's just put a figure here, say 20 kilometers per hour, and you are riding a bicycle at 20 kilometers per hour, it means that in 1 hour, you would travel 20 kilometers. Please understand that this is very important. Kilometers per hour means in 1 hour you travel 20 kilometers. Then from this point onwards, it becomes a proportional problem, you see? Because then in half an hour, you will travel 10 kilometers. See, in 3 hours, you'll travel 60 kilometers. So if this is your speed, so what we are saying here is that 20 times 3 is 60. So what we are saying here is that the distance traveled is equal to the speed. See, if it's 20 kilometers per hour, then in 3 hours, it will have to be 20 times 3. So it's speed times time. So there are 3 quantities in this, usually. They are the distance, the speed, and the time. All right. There are some other small issues that come up here. If 2 people are together at a certain time, if 2 people are together, then it means that they are there at the same time. See, so the time is the same for those 2 people. As we go on, you will see that there are some little features that come up in this problem. So the important thing here is that distance equals speed times time. I don't resort too much to this formula. I will usually try to work it out from first principles to understand what you mean by speed. So here you got a loaded truck travels from Durban to Pietermaritzburg. Okay, so let's try. Normally, you'll put a little diagram here to get an idea of what's going on. So imagine that there is a truck which is traveling from Durban to Pietermaritzburg. Let's call Durban to Pietermaritzburg at an average speed of 60 kilometers per hour, right? So here it is. It means that in 1 hour, it will travel 60 kilometers. Okay, so on this journey here, it travels at 60 kilometers per hour. Excuse me. So after unloading, it returns by the same route, now at an average of 90 kilometers per hour. Returns at an average speed of 90 kilometers per hour. Then the question is, what is the average speed of the truck for the whole journey? Look, we want to say average speed because it's not always traveling at 60 kilometers per hour. When it's starting, for instance, it's starting at 0. When it finishes at 0, it stops. And in between, it travels at various speeds. But overall, the average means that the whole distance divided by the time is the speed. See? Speed equals distance over time. Time is distance over speed. And distance is speed times time. See? So you have speed times time. From there, you can get the other 2 formulae. All right, so now the question is, what is the average speed of the truck for the whole journey? Now, we are not told what this distance is. It's an unknown. So that poses a problem now. So let's give a name to this distance. If you don't know it, give a symbol to it. That's a nice thing about algebra. You can give some symbols. And now, if we know that the distance from Durban to Pietermaritzburg is d, now the average speed of the truck for the whole journey, then it means the whole journey is going up and coming down. The total distance traveled is going up and coming down is 2d, d plus d, right? And to work out the average speed, that will be the distance, total distance over the time taken. Because we said speed is distance divided by time. All right. So now we don't know what d is. We don't even know what the time taken is. But we should not be put off by those considerations because now we still have more information which we have to use. And the first information that we use is that in the up journey, the Durban to Pietermaritzburg journey, that one, the distance there traveled was d, and the speed was 60. So therefore, the time taken is distance over speed. Just remember that. Distance over speed is time. Distance over time is speed. And distance is speed times time. Now this will be time in hours. So the units are given here, right? And this is D. D is supposed to be in kilometers. So we are saying the distance from Durban to Pietermaritzburg is D kilometers. So this is the time taken in the upward journey. And the downward journey, the time taken is the same distance, right? From Pietermaritzburg to Durban. And this time it's 90. So now we know that this is the time taken in the upward journey, this is the time taken in the downward journey. And therefore, your average speed is equal to the total distance, 2D, over the total time taken. Now, we've got the time for the upward journey, and the time for the downward journey is D over 90. So the total time will be the time taken for the upward plus the time taken for the downward. So now this rather clumsy expression is the answer to the problem, but we'll have to try to simplify it. Okay, now the way to simplify this is you look at what number does 60 and 90 go into, a single number, right? An LCM or some common multiple, and multiply this by that number and multiply that by the number so you don't have any fractions. You can see 180 is a good number to take because that is 60 times 3, and 180 is also 90 times 2. So let's multiply. This is a fraction. You can multiply the numerator and denominator with the same number. I mean, this is quite well known. I'll come back to that just now. So you multiply this by 180, and you'll get 360D, 180 times 2. Now, at the bottom, you must multiply 180 as well. What you do to the top, you must do to the bottom. When you multiply this by 180, then the 60 goes into it 3 times, and you'll have 3D. And when you multiply this by 180, it's 180 over 1. And you know how when you multiply fractions, 90 goes into 182 times, so it's plus 2D. So when you multiply this by 180, you get 3D. When you multiply this by, you get 2D. And now you've got at the bottom, you got 360D over 5D. Now happily D cancels. So you don't have to know the distance, right? The distance cancels. 360 divided by 5 is 72. And we are talking about speed, so it's 72 kilometers per hour, because our time is in hours, and the distance is in kilometers. So the average speed was 72 kilometers. A lot of people will say, well, 60, 90, 60 plus 90 is 150, 150 divided by 2. They'll get the answer 75, which will be wrong. This will be wrong. The actual answer is 72. See? So you have to be quite careful with these things, because we have to say, what do you mean by speed? The speed is the total distance divided by the time taken. And if you concentrate on that, you will see that the whole calculation becomes quite different, and you come to this answer. Okay, so that's the first problem. We go on to the next problem. So here you got this problem says Tom was jogging at a constant speed of 10 kilometers per hour. Okay, that means in 1 hour he travels 10 kilometers along a straight road. And Jerry, jogging at a constant speed of 12 kilometers. So Jerry is traveling faster, but he's behind Tom. 600 meters behind Tom. Now the question is, how many minutes will it take Jerry to catch up with Tom? Well, actually, this whole story is wrong. Tom and Jerry is a cat and mouse. I don't know whether you guys read comics, but I used to love the Tom and Jerry. But Jerry was the mouse, and Tom was the cat. Now the cat is not going to try to chase the mouse. That's what they are doing. So I think these people got the names all mixed up. But whatever the case may be, let's try to see what's going on here. So let's draw a diagram. Always nice to draw a diagram because you have a picture of what's going on. So you've got Tom and Jerry. So Tom is here and Jerry is here. And Jerry is following him at 12 kilometers per hour. And Tom is at 10 kilometers per hour. So sooner or later, Jerry is going to catch up with Tom. But the thing is now he is 600 meters behind. Yeah, okay, 600 meters. So the distance between Jerry and Tom is 600 meters. And the question is now, how many minutes will it take Jerry to catch up with Tom? Right. So now, these problems are very nice because they are logical problems. See? So if you think carefully about this, it means now that Jerry is traveling 2 kilometers faster than Tom. Right? So he's traveling, you can say, the problem is the same as saying that if they are both stopped, well, this guy stopped, then this one will be traveling at 2 kilometers. And the question is now, how long will it take him to cover 600 meters? So the question is, how long will it take Jerry to cover 600 meters? So the distance here is in meters now, not kilometers. 600 meters. Always be very wary of the units. But he's traveling at 2 kilometers per hour now. This is the interesting thing. Because you'll have to see that he's traveling at 10, he's traveling at 12. So he's traveling 2 kilometers faster. So in that speed, he has to cover 2. Right. So now this is what you've got. You've got 2 kilometers per hour. So you write it down. 2 kilometers in 1 hour. Right? And you've got 600 meters in what time? See? So this is a good example where you have to understand exactly what you mean by the speed. 2 kilometers, 1 hour. In 1 hour, this guy will cover 2 kilometers. How long will it take him to cover 600 meters? Now you got kilometers, you got meters. So you have to put them into the same units, obviously. So you've got a kilometer is 1,000 meters. So 2 kilometers is 2,000 meters. Now, let's work in minutes, right? Because you got 1 hour, we'll work it in 60 minutes. Right? So now what will 600 meters be? You can see it's a proportion problem, right? So it's actually 600 over 2,000 will be a fraction of 60. See? 4,000 meters will be 2 times 60. So here you've got 600 is smaller. So it'll be a fraction, 600 over 2,000 times 60. Now, you don't have to multiply all these. You just cancel the tens. 10 goes into this. And then you have 2 goes into 6 3 times. So in the end, you got 6 times 3, which is 18, but it's in minutes. See? So this calculation here, I always, whenever I'm working with fractions, I cancel. I don't use my calculator. This is how we learned how to multiply fractions. We take out common factors. 10 goes into the 6 times. 10 goes into this 200 times. 200 goes into 600 3 times. See? 3 times 6 is 18. So you don't have to use your calculator. You can do it all mentally. And anyway, you're not supposed to be using calculators in Olympiad problems. All right, so let's get on to the next problem now. We're going to problem number 3. This is being recorded. So the recording will be on the website, on YouTube. Khotso, can you just come in and tell them about the recording?
Okay, the recording is going to be available on some YouTube page, which you can access it tomorrow around 12 p.m. Yeah.
And how do they get to the recording, Khotso?
They just type South African Mathematics Foundation on YouTube, they will find it.
Oh, I see. They type it out in full. South African
Yes,
Mathematics Foundation. And
yes,
then go
in
and
full.
search for the recording of the junior training, Siyanqoba, Olympiad, something like that. And
No,
you will
just
find the recording.
yeah.
All right. Is that correct, Khotso?
It is correct, Prof.
You have to search for that one. All right. So the next one is Adam and Betty travel from Adam's house at the station to Betty's house. Now, once again, I'm going to draw a picture to see what's going on here. Right. So they start at a station. So I'll put station here, S for station. Now, from Adam's house at the station. Oh, all right. So Adam, he stays at the station. Now, Betty, to Betty's house. So Betty, she lives in her house. Now, Betty first takes 30 minutes train. So they both travel now. Betty takes a 30-minute train ride. So let's see, what is Betty doing? Betty first takes a train ride. From the station to her house by train. But what is important is she takes 30 minutes to do this. So you know the time that Betty takes to go to a house. But then she doesn't reach a house. She then walks the remaining 1 kilometer. So the train station is not at a house. It's 1 kilometer from a house at 5 kilometers per hour. So she travels 1 kilometer at 5 kilometers per hour. Now we can't stop there. We must say, so 5 kilometers in 1 hour. We'll make it 60 minutes. So her speed is 5 kilometers in 60 minutes, but she only has got 1 kilometer to travel. So therefore, the distance she travels, the time that she will take, at 5 kilometers in 60 minutes. So 1 kilometer, she'll do it in 12 minutes. 60 divided by 12. So therefore, the walking part will be 12 minutes. So she takes 30 minutes by train. The walking is 12 minutes, and that is 42 minutes. So it takes Betty 42 minutes to reach a house. All right, you'll notice that I didn't read the whole question. I'm taking the information and I am trying to make as much information conclusion from that as possible. And I now concluded that Betty takes 42 minutes to get to our house. So the story about Betty is over. Now, Adam and Betty, they leave at the same time, all right, from the station at Adam's house. And Adam drives a car by road. Oh, so Adam is better off. He travels by car and he travels the entire journey, it says here, and it's 84 kilometers long. So it's quite a long distance. So it's 84 kilometers. So Adam travels a distance of 84 kilometers from the station to Betty's house. Now the question is, how fast does he travel in kilometers per hour to arrive at Betty's house at the same time as Betty? So in other words, they both reach at the same time, they start at the same time, and they reach at the same time. So it takes Betty 42 minutes. So it should take Adam also 42 minutes because they start at the same time and end at the same time. And you need to know what is Adam's speed, right? So now this is an interesting question. So what have we got? We've got that Adam, he has to cover 84 kilometers in the same time as Betty in 42 minutes. See? And the question is, what is his speed in kilometers per hour? In other words, the question is, how far does he travel in 1 hour? Kilometers in 1 hour, how far does he go? Right. Now you can do this in two ways. You can say in 60 minutes, that's 1 hour. Right? So if it takes him 42 minutes to cover 84, then 60 minutes, it'll be more, 60 over 42 times 84. Right? Again, it's all proportion. So you've got 42 and 84, 60 will be 60 over 42 times 84. And happily, 42 goes exactly into 84 two times. So it's 120. And 120 means that this is all in kilometers, and we worked it out in 1 hour. In 1 hour, so he will travel in 1 hour. He'll travel 180 kilometers. So that means his speed is 120 kilometers per hour. Okay, so that's the answer to the problem. It's traveling pretty fast to do that. The other way of doing this thing is if he travels 84 kilometers in 42 minutes, then in 1 minute, I like this method. Bring it down to 1. Right? 42 minutes, then in 1 minute, you will travel 2 kilometers. Right? I prefer working it like this from first principles. In 42 minutes, he does that. And we want to know what he does in 60 minutes, which is 1 hour. Obviously, now it's 60 times 2, which is 120. Come to the same answer. Right? So that's the answer to the problem. So again, it's all about proportion and understanding what do you mean by kilometers per hour. So the question is, how many kilometers does he travel in 1 hour? See, that's the question. How many kilometers in 60 minutes? That's your unknown. All right, so let's just get on to the next problem. So even if you didn't copy this thing down in good time, when you go to the recording, you have all the time in the world to go slowly and go through the whole thing so that you understand everything. Okay, I think somebody seems to be writing on my page. Please don't do that. Okay. So the next problem is, all right, so you've got somebody messed my page up. Anyway, Saras, you pronounce this as Saras, would like to become an Olympic sprinter. A younger sister, Lakshmi, would rather play football, but helped Saras by racing against her. All right, so Saras is a good runner, and a sister, a younger sister, she uh, she races against her. You know, usually you need somebody to be a backup, to be a good sprinter. So when they tried the 100-meter dash, so both of them tried to cover 100 meters. Saras crossed the winning line when Lakshmi was still 20 meters behind. So I've got this in a picture here. So there's your starting point, there's your end. And you notice it's 100 meters. So I've drawn my diagram. So start, end. And Saras, when she is at the end, Lakshmi is 20 meters behind. All right, so I got S here and Lakshmi is 20 meters. So whenever Saras travels 100 meters, Lakshmi will only travel 80 meters. All right. Now, Saras crossed the winning line when Lakshmi, oh yeah, when they tried the one, yeah, okay, I'll finish that. Now, Saras wanted something more challenging. So it was agreed that she would start 20 meters behind the starting line. So this diagram here says that Saras now, as she's behind Lakshmi, 20 meters behind her. So she's got a longer distance to travel to get to the end. Lakshmi has got a shorter distance. Right. Now they both run. They both ran exactly the same speed as in the first race. Now the question is, where were Saras and Lakshmi when the winning line was crossed, and who arrived there first? So it's a very interesting problem. Right? She was given there a start, 20 kilometers, 20 meters. So who wins this race? Right? And by how much? One will be at the end, right? And they want to know, and where were they when the winning line was reached? Well, obviously the winner will be at the end, but you want to know where the other person was. All right. Now, this is quite a simple problem. If you don't worry about formulae and everything, what you do is, Saras is traveling, she's starting here. So even here, she will, when she covers 100 meters, listen very carefully to this. When she covers 100 meters, then Lakshmi would have covered 80 meters. Now let's see. When Saras covers 100 meters, that means she covers 20 and another 80 here. And when Saras covers 100 meters, 20 plus 80, this is 80 here. Then Lakshmi would have covered the same 80. So Lakshmi and Saras would have been together at this point here because she's only got 80 to travel. And Saras would have traveled 100 and Lakshmi would have traveled exactly 80. So they are together here. So now you can see who's going to win because Lakshmi is the slower one. So Saras will win. But now the question is, where was Lakshmi then? Okay, so now we have to say, what's the distance that Saras must travel? She needs to travel 20 meters to get to the end. And you want to know where Lakshmi was. All right, now remember, again, it's a proportional problem. Saras does 100 meters to Lakshmi, who does 80 meters. Right. Now, Saras needs to travel 20 meters to get to the end. Right? Now, that is 1/5 of this, isn't it? So it means that Lakshmi would have traveled only 16, because this is 20 is 1/5 of this. So it's 20 over 100 times 80. That's 1/5. 5 goes into 80 16 times. 16 meters. Remember, we're working in distances here now. So Lakshmi would have traveled 60 meters, 16 meters. So she's there somewhere, and Saras will be there. You got 20 altogether. So Lakshmi would have been 4 meters from the finishing line. So the question was, where were both of them? Right? And Saras is at the end, obviously she won, and Lakshmi is 4 meters behind her. So despite the fact that she's got 20 meters lead, Saras still beats her. So you can see there's only pure logic here, guys, right? And mostly it's just proportion and understanding what is happening here, getting the picture, get a full picture of what's going on, imagine the story, and go ahead and solve it. See, there are hardly any calculations here, right? Mostly it's just understanding it. Right? Very simple calculations. Okay, so let's get on to the next problem. Okay, so now this problem here says Erika noted that a train to Musenberg took 8 minutes to pass her. All right, now let's just try to understand this. I'm going to make Erika stand somewhere. So Erika is standing here like this, and she sees a train which is going to Musenberg. And this train took 8 minutes to pass her. So there's your train here. And to pass her, it means the train travels its full length. We don't know what the length of the train is. Let's call it X. It's going to Musenberg. And Erika is standing here. And it takes 8 minutes to pass her. So what does this mean? It means that this train, you can work out its speed now. If you know, the train, the Musenberg train, this is in the Cape somewhere, train, right, it takes, we'll say that the length of the train is in meters. We don't know what this length is. It's X meters in 8 minutes. So this is the speed of the Musenberg train, right? Now, as I said earlier on, I'd like to bring it down to 1 minute. So in other words, in 8 minutes, it travels X meters, and therefore, in 1 minute, it will travel X over 8 meters in 1 minute. Right. Okay. Now, this is the Musenberg train. Now, the train which is going to Cape Town, it says here A train in the opposite direction to Cape Town took 12 minutes to pass her. Right. So let's just have a look at that picture there. So you have, again, Erika is standing here somewhere. And for the train to Cape Town, this, if you read further along, it says that the train is 150 meters long. So you know how long this train is. This train is 150 meters long. Right? And it's going in the opposite direction to Cape Town. And how long does it take? It takes 12 minutes. So the full length of the train to pass her, the Cape Town train will travel 150 meters because its length is 150 meters in 12 minutes. Because it takes 12 minutes to pass her. So again, if you bring it down to 1 minute, now you see you got 8 and 12. So if you bring it down to the same unit, then it helps us a great deal. 150 over 12 in 1 minute. Okay, so now you know that in 1 minute, this Musenberg train travels x over 8 meters, and the Cape Town will travel 150 over 12 minutes. Now 150 over 12 is, you can simplify it because 6 goes into this 2 times, 6 goes into this 25 times. If you cancel, 25 divided by 2 is 12,5. So it's 12,5 meters in 1 minute. Okay, now let me just take these diagrams out now. Ooh, I took everything out. Oh, sorry about that. Hopefully I can remember what I had. Uh, let's see what the question is. The trains took 9 minutes to pass each other. Ah, so here you are saying that to pass each other. So Erika is still standing here, but this time you got well, there's a diagram here. There's Erika here. So you got a train traveling this way to Cape Town, and this to Musenberg. So to pass her, that means this train here would have gone. This is a little bit tricky. So Erika is standing here. The second train, the Cape Town train, it would have traveled. The front of the train is here, right? There's 150 here. And this other train is going this way, is X, right? Because its length is X. And the total distance for both trains to pass it will be X plus 150. This is, when this is right there, this is there. So the total distance traveled by these two trains is X plus 150. So the distance between the trains is X plus 150, right? And it took 9 minutes. So in 9 minutes. But you must remember that in 1 minute, the distance between the trains see, in 1 minute now, one train travels x over 8 in one direction, and the other one is traveling 12 and a half. That's what I had before, 12,5. So in 1 minute, the distance between the fronts of the trains is x over 8 plus 12 and a half. We are looking at the fronts of the trains plus 25 over 2, right, in 1 minute. So in 9 minutes, the distance between their fronts, we're looking at the front of the train, right, x, and this is the front of the train. This is traveling this way, this is traveling this way. So we're looking at those 2 points. How fast are they separating? Will be 9 times this. But we just saw that in 9 minutes, they would have traveled x plus 150. So you've got an equation here. Now, 9 into x over 8 plus 25 over 2 is equal to x plus 8, x plus 150. We saw here that it takes 9 minutes for these 2 trains to travel. The fronts will be separated by x plus 150. Look, it's quite a tricky problem. I have to admit that even I was struggling to understand this problem. So if you just focus on the fact that you are looking at the separation of the fronts of the trains, that is what you're looking at, to say that they pass each other. See? So now you have an equation in x, and you can try to solve this. And the way to do that is multiply by the common denominator. I don't like fractions. So I'll multiply both sides by 8. So it'll be 9. I wouldn't multiply this by 8. I'll multiply this by 8 to get rid of the fractions. 8 plus 1. And yeah, if you multiply this by 8, then 2 goes into 8 4 times. 4 times 25 is 100. So here you'll have 8x. You have what you do to this side, you must do to this, to do to that side. 8 times 150 is 1200. Excuse me. So now you got rid of the fractions. The way to get rid of fractions in equations is multiply by the common denominator. What I call flatten the expression, flatten it. So you multiply by the common denominator, and then the denominators cancel. So they get flattened. So what you do to one side, you must do to the other side. Now you can solve for this. This is 9x plus 900 and so on. I'm not going to do it. It's very simple. So x is 300, and we are working in meters. You must give the units, because we said that the length of the train is x meters. Right? I should have said that. Let x be the length of the Musenberg train, called the M train. Right? That is what we said, Jan. So then we, I must have had that before, but I deleted it. So we solve for x. In other words, we've got the length of the Musenberg train. That's the question. What is the length of the Musenberg train? We call it x, and we solve for x. So in mathematics, this is a huge plus. You see, the idea is to use the given information to get an equation. Right? And it always happens in problem solving. Somehow you'll try to get an equation. If you've got an unknown, try to get an equation involving that unknown, or maybe equations, and then solve. Because in school you learn how to solve for equations. I think some of you are in grade 8, so you might not have done this, but let me just quickly do that. Unfortunately, I forgot that. So what do you mean by equations? You see, if you got an equation, for instance, if I say 2x plus 6 equals 3x minus 9. And you want to know which x makes this correct, right? Now, you don't know what x is, but when you substitute x, you must get a number here, and you must get the same number here. So that is what you call an equation, and you try to solve for it. And the way to do this in grade 8 is you bring all the x's to one side. And to do that, when you take this 3x, when you cross the equal sign, the 3x becomes, it changes sign. So you have 2x minus 3x, all the x's to one side, there's a minus 9 still here, right? You'll be working with negative numbers. And this plus 6, you bring it to the other side. There are no x's there, so you bring it to the other side. But again, it changes sign. So now you say 2x minus 3x is negative x, minus 9 minus 6 is minus 15. So x is 15. See? And when you substitute 15 into this, 15 times 2 is 30. You'll get 36 here. When you substitute 15 into this, 15 times 3 is 45. Minus 9 is 36. Bingo. Right? So you actually worked out an x which will make both of them equal. When you put other x's, they wouldn't be equal. But x equals 15 works. And this is how you calculate it. Okay, so that's a very, very quick lesson into equations. When you are doing second round Olympiad, you should be very familiar with all these equations, but just in case some of you didn't know it, I went through that. Okay. Now, I noticed that many people are coming in late. I just want to point out that this class starts at 5 o'clock. So you should be here at 5. I can understand sometimes you may have something else to do. You come in late, but it is not proper to come in late to a class. You should make a choice. We will allow you to come maybe 10 or 15 minutes late, but people are coming in at, it's almost 6 o'clock now, 1 hour late, which is not very nice. Okay, try not to come, try to make it here in time, because you missed a lot of very, very important things that we said about distance time problems, and you missed all that, unfortunately. Okay, the next one is Ndu walks at a constant rate, right? He takes 72 seconds to walk up an escalator, which is moving downwards. Oh, no, this is a little bit difficult here because you got an escalator. So it's not a straight path now. So how do you count the distance, the length in an escalator? I think we should work in steps. So we'll talk about steps. Right? Escalator has got so many steps. So we don't know how many steps it's got. Maybe the problem will tell us how many steps. But he walks at a constant rate. It takes 72 seconds to walk up an escalator, which is moving downwards. Okay, now we don't know how many steps there are. So suppose there are these steps. Anything. So I'll just call it D in the escalator. All right, so Ndu is starting here and he goes to the top and he covers the D steps in 72 seconds. When he is walking up, let's just put that up, he does D steps in 72 seconds. Now, Mdu has got his own speed, and the escalator has got another speed is coming down. It's working against him. So yeah, there's a problem. You've got two things which are moving at the same time. Mdu is walking up, and the escalator is resisting him. It's coming down. So now the question is now, what is his actual speed? Okay, we don't know what his speed is. Suppose we say, suppose induced speed we're working in steps here, is maybe x steps. And they're talking about seconds here. So we rather say in 1 second. Okay? So now that's his speed. The speed is what's the distance he covers in time. Right? Suppose that is his speed. And the escalator has got its own speed. And suppose escalator speed is y steps in 1 second. All right? So whenever E walks x steps upwards, the escalator has moved y step downwards. Right? So the up journey, E will only cover y minus x steps per second. In the upward journey. Because the escalator is coming down. No, it'll be actually, yeah, his speed is x. So he reaches the top. So x must be greater than y. So it's x minus y. Why is x greater than y? Because his speed is faster than the speed which is coming down. If the escalator is going down faster than him, he'll be moving backwards. But he reaches the top. So in other words, his speed is, it'll be x minus y steps per second, right? And it takes him 72 seconds to walk up the escalator. So in other words, in 1 second, he travels x minus y upwards. So 72 into x minus y is equal to the number of steps in the escalator. The whole distance. Because it takes him 72 seconds to reach to the top. So he covers so many steps in the escalator. This is an example where your units are not meters or kilometers. Yeah, the units are steps, but it doesn't really matter, right? Whatever the units are. Okay. But now it goes on to say that 36 seconds to walk down the same escalator. So when he's walking down now, when he's walking down, the escalator is helping him. The escalator is also moving down, right? So in the down journey, when he travels x steps, the escalator is also traveled y steps downwards. So in 1 second, it'll be x plus y steps in 1 second. So the down journey is going to go faster because the escalator is traveling y and x. So they both combine to make that he's traveling x plus y steps in 1 second. Now it takes him 36 seconds to cover the distance. So here it's 36 into x plus y. In 1 second, it travels x plus y. So in 36 seconds, this will be the number of steps in the accelerator. The same thing as before. All right, so now this is quite something. I'm going to just remove all this because I need the space. So we got the whole number of steps in the escalator. We got it in two different ways here. We've got 72 into x minus y is one way, and the other way is 36 into x plus y. So they both represent the same thing. They both represent the number of steps in the escalator. 72 into x minus y equals 36 into x plus y. Okay, so when you expand this, okay, the grade 8s, I hope you know that when you got a into b plus c is ab plus ac. A times b plus a times c. So this is 72 times x minus 72 times y equals 36x plus 36y. You got two unknowns here. So let's bring all the x's to one side. 72x minus 32, 16, 36x. And this, when you take it to the other side, 72y, become plus 72y, plus 36y, gives you 108y. So you have x is equal to 3y. Right. We're still nowhere near the solution. The question is, how many seconds would it take him to walk up or down? All right, now, what is the question there now? The question is, if the escalator is switched off, that means there's no y. The y is 0 now. The escalator is not forcing him, so he is only traveling in x's now. Right? So he's traveling at x steps per second in 1 second. The escalator is switched off. There's no resistance. So how long would it take him to walk up or down? So he has to travel x steps, right, in 1 second. That's his speed. Oh, it's sorry, man. I don't have much space here, so I have to keep rubbing these things out. So the question now is, in 1 second, it travels x steps. You want to know how many seconds it travels what? Now, what is the length of the x? We saw that x is 3y, right? So x is 3y. And y is x over 3. So the number of steps in the escalator, we've got x is 3y, so it's equal to 72. X is 3y, so 3y minus y is 2y. So it's 144y. X is 3y, I can put 3y. 3y minus y is 2y. So the number of steps in the accelerator is 144y. So he has to travel, he's traveling in 1 second. Sorry, in 1 second. Now you want to know how long does it take him to travel 144y. Now we don't know, you got x here and you got y is here. But again, you can say 3y is x, isn't it? So if 3y is x, so this is, if you take the 3 out from this, you'll get 3y times 48. And 3y is x, so this is 48x. So what we are saying is in 1 second, he covers x steps. And in how many seconds would he take to cover? We worked it out in x again. It's 48x. So the answer is quite clear. Answer is 48 seconds. This is a hard problem. Right? But mostly it's about proportion. as you see. And you have to keep track of what's going on. X is his speed, and y is the speed of the escalator coming downwards. And you have to translate those ideas into equations. So his actual speed upwards will be the difference between the two speeds, because he's got resistance. It will be x minus y. And the question is now, how far does he travel? He travels the full length of the escalator in that time, right? And it takes him 72 seconds. In 1 second, so much, the full length will be 72 times that. The same way in the other way, the full length is 36 times the sum of the two. But the both of them are the same thing. They are the full length. So we know the full length is going to be that, right? So we need to calculate this thing here. No. We need to calculate how long it takes me to walk up or down. So that is why we know the distance is 48x, and it'll take him 16 seconds. Okay, it's a tricky problem, admittedly. So remember, now you are in second round of the Olympiad, so they're not going to ask you trivial questions. Okay, we still have more distance time problems. Just give me a break. I need to put the light on. The next problem, it says now that A and B run at a constant speed in opposite directions around an athletics track. Okay, and so now you've got a track, a circular, maybe elliptical or whatever it is, but we can assume it's a circular track. So let's draw this track. Oh, what happened here? Right. Okay, so I'm going to draw a track here, which is circular. All right, now these two guys are running on these tracks here. How do I move this thing? I think there's a way of moving this, but I don't know. Okay, it doesn't really matter. So what happens is they're running in opposite directions. So somewhere along the line they start. Now A and B, they run at constant speeds in opposite directions. So one guy, A, and B runs in the other direction. Okay, so in other words, they will be crossing each other. Right. Now, they begin at the same time from the same point, and for every 2 laps that B completes, every 2 laps that B completes, A completes 3 laps. Now, what is the meaning of that? For every 2 laps that B completes, A completes 3 laps. That means A is traveling faster than B. In fact, he travels 1.5 times the speed of B, because B only covers 2 and he covers 3. So for every 2 laps that A covers, B covers 3 laps. So the ratio of the speeds will be 3:2. Okay, even if you miss that now, we'll say, so if you take a full lap here now, right? In other words, A, when he covers 3 laps, A is faster, so he'll be here somewhere, more than half, then B will come a small bit here, right? So you want to know where they will first meet. So A, let's put it this way. the A's speed is 1.5 that of B, right? So the ratio of the distances that they cover is 3:2. That's the important thing. That the distances, A, when he covers 3, B will cover 2. Let's put it that way. So to cover entire one lap, right? That means A would do 3/5 of a lap, while B will do 2/5 of a lap for them to meet. When they meet, this part will be 2/5, that part will be 3/5, and they will both together add up to one lap, right? So if you want to know where they meet the first time, it means because the ratio of the speed is 3:2, then it travels 3/5 of a lap, and B will travel 2/5. So this is where they meet now. Now this is a tricky question. And then now they say this is the first time. This is a meeting, first meet. Now they keep running. They begin at the same time from. How many times do they pass each other when A finishes 10 laps? So A is traveling 3/5 of a lap to meet him, and he finishes 10 laps altogether. Now, when he goes round and round and round, this guy will keep going round and round this way, and they will meet several times. And the question is, how many times do they meet? Right? Looks like a pretty tough question. But if you think about it, it's like this. In the beginning, A and B were together here, right? Starting point. Now here, again, they are together. So now the whole scenario repeats itself. A will cover another 3/5 before they meet, right? And then again, the scenario repeats itself. A will cover another 3/5 when they meet. So A will cover several 3/5 right, of a lap, and you want him to see. You want to see how many 3/5 there are in 10 laps. So how many 3/5 must you add to get to 10? So that is the question. Right? It need not be an exact amount, but you want to know how many times they cross. They will cross each time there is a 3/5 of a lap. Right? So if you can think about this, but actually the answer is you have to see if they meet n times, say n times, then you want 3/5 plus 3/5 n times, which is 3/5 multiplied by n. You want it to be less than 10 because you want to see when is the last time they meet. So the way to do that is to see which is the largest value of n, which will make this true. That's a little bit tricky, right? But you're looking for the largest value of n, the number of times they meet. Right? They need not meet exactly at the starting point, you see. But you want this to be how many times do they actually meet? It's 3/5 times n is this. Or otherwise, you can say suppose 3/5 times n equals 10. You can do it like that. And then what happens is, then n is equal to multiply by 5 times 10, divide by 3. If you multiply by 5, you get 3n. The 5's cancel. It's 50. So 3n is 50. So n is equal to 50 over 3. That gives you 16 2/3. Right? And that's not an integer. So it means that 16, the number of times they meet is 16. Right? And in another 2/3 left, there will be at some other spot. So the number of times they actually meet is 16, but then that is why we said when you say less than 10, then you want to know which is the largest value of n, which makes us less than 10. If you make it n equals 16, 16 times 3 is 48, right? And that they would have covered 9.6. That's 48 over 5 laps altogether, and that's when they meet, right? And beyond that, they would have covered more than 10 laps. All right, so the answer is 16. Another tricky question. So you can understand why people are afraid of these problems, but these are difficult problems. These are Olympiad problems. But in school, they don't ask you such difficult problems. Hopefully, you'll be able to answer all the questions in school. Usually, these questions occur in the last thing because they become problem solving. All right, and they usually carry a lot of marks. Okay, now the next one. Now we are finished with all these uh, distance time problems. You will be happy to note, and we've got this. Now, I've just thrown this thing in. You guys are juniors, but we expect you to know certain formulae. Right. I have said this before, and I'm going to say it again. An arithmetic sequence has a common difference. I'll tell you what this means now. It means that you got a sequence of several numbers, and the difference between any two consecutive numbers is the same. That is why it's called common difference. So in other words, you add the same number to get to the next one. Right? It's the same thing. You're adding the same number, and we call that D. So what happens is that if your first number, if you know, if you call A the first number, then your sequence is because you're adding the same number all the time, be A plus D, A plus 2D, and so on. So that's the sequence. They got a common difference. Right. So you have a first term, a second term. These are called terms. Third term, fourth term, and so on. You can see now the nth term, if you don't know what the position is, if you say the nth term is it's A plus, and the 3 is just 1 less than n. So you have n minus 1d. This is the nth term. So the symbol for the nth term is t, n, t for term, nth term. So this is the nth term. Now, the nice thing about this is that you can actually add all the terms, right? If you add up all the terms in an arithmetic sequence, you got two formulae. This is the first term plus the second term plus the nth term. There's a formula which says that it's n over 2 times the first term plus the last term. In an arithmetic sequence. So there's a whole section in your syllabus which does this. Right, so it's actually like the average of the first term and the last term, you divide by 2, add them, divide by 2, and multiply by the number of terms. That gives you the sum of all the terms. Right? The sum of all the terms. This is a sequence here, there's no sum. Here we're adding everything, right? Like in this problem here. So bearing that in mind, if you look at this is an arithmetic sequence. The top sequence is an arithmetic sequence because, well, it's not a sequence, it's a sum. But the terms in the sum they obey the law that you're adding 2 all the time to get to the next one. Right? So you're adding 2 all the time. So you want to know how many terms there are. So this is an arithmetic sequence because you're adding 2. And here too, you're adding 2 at the bottom as well. Right, so how do you solve this problem? Now, I need to know this n is a number of terms. Right. For the bottom one, we can actually count the number. It's 2, 4, 6, right? Up to 2n. So if you divide by 2, you get 1, 2, 3, all the way up to n. So there are n numbers at the bottom. 2, 4, 6, you got 3 numbers. So 2, 4 up to 2n, you got n numbers. And here you will have the same number at the top there because this is 1 less than this is 1 less than this, 1 less than this, and this 1 less than. So you got n numbers here altogether at the top as well. Right. So using this formula here, the top is the number of numbers, which is n, over 2. And it's the first term. The first term is 1. We can use this formula because this is arithmetic sequence. There's a common difference. The last term is 2n minus 1. That's the top numerator. Denominator, you can use the same formula. Again, you got the same number of terms, n. And this time, the first term is 2. T1 is the first term. And T with the n at the bottom is the last term. And that is equal to 2025 over 2026. All right, so you just need to know this particular formula. The other formula which you should know, but fortunately here I don't have to go into that. We don't have much time for that. And I think I've already done this. I can't remember, but I think I would have done this. So now you have an equation with one unknown, and that's the problem. See, as I said, you try to get equations with that unknown, and then you try to solve it. And from this point onwards, it's just a matter of using algebra, and I can do it for you because it's quite easy. 1 minus 1 is 0. N over 2 times 2n. 2 cancel off. So you get n times n squared at the top. And here, this 2 can come out as a common factor, right? It's n over 2. If you take 2 out from there, you get 2 into 1 plus n. N over 2 times 2, the 2's cancel. So at the bottom, you got n into 1 plus n. At the bottom, you got n into 1 plus n, and that is 2025 over 2026. But then this is n squared and n, you can cancel the n's as well. So this is n over, this is n times n. 1 plus n, I'm going to write it down as n plus 1. And now you can see what n is staring at us in the face. Because the bottom is 1 more than that, you see. And this is the bottom is 1 more than that. So n must be 2025. Just by inspection. You don't have to do any calculation. You can see the numerator is 1 less than this. So this has to be, the numerator has to be n, 2025. Okay, so this problem here, it can be done without too much of hassle. Just you have to know a couple of things about arithmetic sequences, and then algebra takes over. You have to be quite good in algebra. You can see often we are doing equations and we're simplifying and so on because it leads to equations, and from the equations onwards, it's all about algebra and simplifying and dividing and working with fractions. So all that you must be quite familiar with. Okay, so we get to the next problem. I don't know how many there are, but so you got this problem here. Why is there a big line here? Let star x, okay, we're going to call the star of x. Now, there's a funny little thing here. Be the sum of the digits of the positive whole number x. So this thing here has got a meaning. Star of x, whenever you see this, it's equal to the sum of the digits of this number. Like here now you got an example, star of 8. 8, there's only one digit, and when you add the digits, you're going to get 8. So you got 8 here. But here, if you look at star of 123, this number here is 123. If you add the digits, you get 6. So that is why star of 123 is 6. Right. Now, the question is, for how many different two-digit numbers x is star of x equal to 3? Oh, there's a double star. Oh, okay. Now this is getting a little bit weird here. So you got star of, and there's a star inside here. That's equal to 3. Oh, now how you have to translate this into languages here. Okay, the star means the sum of the digits. I'm looking at the star there. The sum of the digits of the inside of star x. That's the inside. Right? Like the inside is 1, 2, 3 is 3. So the sum of the digits of star x is 3. So what will the digits of star x be? So if the sum of the digits is 3, how can you get the sum of numbers equal to 3 here in a digit? You can only have, say, 1, 1, 1. That sum is 3. Or you can have 1, 2. You can even have 3, 0. Let's talk about two-digit numbers. But you can't have 0, 3 because that's a one-digit number. You can have 2, 1. All right? So the sum of the digits is 3. So the star x would have had to be the sum of the digits of star x is this. It's going to be 111 or 12. Oh, it could just be 3, by the way. Yeah, it's 3, not 30. Because the x is a two-digit number, not star x, right? So it could be 3, or it could be 21. Now, that is the possibilities for star x, because the sum of the digits of star x is 3, and you'll see it's in these cases, and there's no other. If you check it out, these are the only possible numbers where the sum of the digits is 3. All right, so now what will the x be? Now, the question is, what is x? So you got the sum of the digits of x. The star x is this. Sum of the digits of x is 111 or 12 or 3 or 21. Because star of x means the sum of the digits of x. See, I'm translating it exactly as they are saying here. And yeah, all right, but these are two-digit numbers. Now, x is a two-digit number. Sorry, my writing is very bad here. You can't read it nicely. X is a two-digit number. Now, the sum of the digits of x can't be 111. It's a two-digit number. Goodbye. It's impossible. The sum of digits can be 12, can be 3, but it can't be 21. Because a two-digit number, the largest sum you can have is 99. 99, 18. Can't be that. So now you've got that the sum of the digits of x is either 12 or 3. Okay, so let's take 3. I want x to be a two-digit number, which has the property that the sum of the digits is 3. So you can have 12, you can have 21, or you can have 30, right? These are two-digit numbers. X is a two-digit number, whose sum of the digits is X is 3. But here, with 12, you got more possibilities. Now you got the sum of the digits of X is 12. So the smallest, you can't have 1 and 11, 2 and 10. You can have 3, 9. You can have 3, 9. The sum of the digits is 12. 4, 8. Let's increase the first one. 5, 7, 7, 5. I'm sorry. 6, 6, 7, 5, 8, 4, 9, 3. Those are the only two-digit numbers which add up to 12. I'm doing it systematically, starting from the smallest. The first one is 39. The next one is 48. Make sure the sum of the digits is 12. And the question is, how many different two-digit numbers have you got? Then you count them now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is 10. There are 10 two-digit numbers which have the property that double star X equals 3. Right. This is not a hard problem, but it's, you have to know exactly what you mean by the statements. So you have to translate what you mean by star of X. If you write it in full like this, then you don't get confused. See? All right, so that's the answer to that. And I think I got just one more. So it's already 6:33. I'm beyond the time. If some of you want to go off, you're quite free to do so, but I just got one more. And oh, that wouldn't take long. Okay, so this one here is an interesting problem. You want A, B, and C to be positive integers such that, terrible thing here. You got a funny looking object. You got 30 over 13, you got A, and you got this, and you got this. And if you haven't seen this before, it becomes very difficult because now you say, I got three unknowns. How am I going to find this thing? But actually, the answer is very, very simple, as you will see. So what really is happening here is that I'm going to say 30 over 13. Let's start on that side. Right. I'm going to write this as a mixed fraction. 13 goes into 30 two times. And the remainder is 4. So you can write it as 2 and 4 13ths. 2 times 13 is 20, 26 plus 4. So this is really 2 and 4 13 is 2 plus 4 over 13. Can you see now? You got 30 over 13 equals 2. There's your 2. So A is 2. Straight away you can see. Right? But now you want this to be 1 over something. Right? This part here. So you can write this as 2 plus 4 over 13. You can write it as 1 over. But 1 over what? 1 over 13 over 4. Right? When you say 1 divided by 13 over 4, then you can invert it to get 4 over 13. So you're nearly there. There's the 1 there and 1 there. But now you got 13 over 4. And again, that is a mixed fraction. 13 over 4. 4 goes into 13 3 times. Right? 4 goes 3 and it's 3 and a quarter. Right? And then you can write this as 2 plus 1 over the 3 and a quarter. You can write it as 3 plus 1 over 4. And you got it exactly in that form. A is 2, B is 3, and C is 4. A plus B plus C is 9. 5 plus 4. And that's the answer to that problem. Okay. If you know how to do it, it's easy. But if you don't know how to do it, it can be very hard. So it's just a matter of, it's all about just division, writing a mixed fraction. So it's all about that. Okay, this is actually belongs to a subject called continued fractions, this kind of a thing. But let's not go into that. Thank you very much, guys. And please remember to sign the register. Also, have you got the link? Also, you can stop the recording now. And Khotso said is going to give you the link. He's got some information on the chat part. Okay, now there are some other things there. All right. Okay, I think some people have written some things down in this, and I think Khotso can read that. But Khotso, you're not coming in. Are you there? All right. I think sooner or later he'll send you that link which says, which will have to say that I was present at this meeting, at this class on the 30th of July, the junior class meeting. Please tick the relevant box. All right. Okay. Now, guys, thank you very much for being here right through. We've got a good number of 33 participants. And I want to thank the senior people from each center, Dr. Mpofu and Dr. Tatira. Thank you very much for being here. And hopefully you'll be... Oh, Heman is here also. Hi, Heman. I want to welcome Heman. Heman is a project manager for the South African Maths Foundation, and he helped to set up all these meetings. Okay, so if there are any questions now, you can raise your hands. And those who want to leave, they can leave. But if anybody has got a question, they didn't understand something, they want me to do it again, I'll be quite happy to do it. But just raise your hands. There is a react thing at the bottom. It's got some token there, an icon. You can press that, and then I will know who is asking the question. If there are any questions, you can put your hands up. Okay, so I don't see any questions. So it means that, oh, Akolwa, can you please ask your question? You can put your microphone on now. Oh, you've got something here. You're a grade 8 learner from Sobantu Senior Secondary School. I've got that message.
Yes, sir.
All right. Okay.
I wanted to ask, is it necessary that we type the assignment, or we can use our handwriting?
Oh, I'm sure you can do your handwriting. Benjamin, can you answer that? Your assignment, Dr. Mpofu. You don't have to type it in. They can write it as long as you're clear. All right. Good. It's a good thing you remind me about the assignment. There is an assignment that has been sent to you. I think you sent it earlier today, and try to work that. Benjamin?
Okay. No, thank you, Prof, and good evening. No, actually, the assignments, they are written with a ballpoint on paper. Then afterwards, you are going to scan the solutions and paste them on the tablet that will be provided to you by the tut. That's how we operate. Thank you.
Okay, so you can scan that and make a printout of it and write your answers, and then scan it again and send it through. You can do it like that. Or if you want to type it, you can type it, make it easier without having to print it. Yeah, that poses a problem if you don't have a printer. Although if you've got some method of writing on that. Okay. Any other question? Okay, thank you for that question, Akolwa. I'm sure it will have helped somebody else. All right. So if the okay, Norman.
Sorry, sir. Can I just ask, can you please send the assignment through on the WhatsApp group?
The question is about the assignment. Heman, I'm looking to Khotso to answer these questions, but he doesn't seem to be around. Just repeat your question, Norman. I couldn't hear you.
Could you please send the assignment?
Yeah, he sent the assignment, or if he might not have sent it already, but I think he sent it this morning. And you have the assignment page on which to work out the assignment. It's been posted to you. It's posted to all the people who are registered in the course. Any other question?
Hi, Prof.
right.
I've posted questions on the
Yes,
WhatsApp,
Ompila.
on the meeting chat.
Yes. You put something on the chat?
How do you find out our tutor? And can I receive the link to the WhatsApp group, please?
The link to the WhatsApp group. Look, I think I that is an admin problem. I come here, I teach and go away. We have got two admin people who are here, but Herman is here. Herman, maybe you can answer that if you are still here. I see his name on this. Herman Bosman is a project manager. All right, so
Hello, Prof. Can you hear me?
yeah, so there are questions being asked. I don't know the answers to them. Please ask that question again,
Prof.
sir.
Can you hear me?
Right. Yeah, I can hear you now. Yes. I think Ompila asked the question. Question? Something about a WhatsApp group.
It was about the link.
Yeah, can you just ask Khotso the question? He can answer it.
Can you please like send the link to the WhatsApp group?
Oh, send a link to the WhatsApp group. Khotso, can you answer that? I think it'll be easier to send a link to you, and then you can send it to the rest of them. Isn't that the way it works? I'm not sure.
I'm not sure, but how do I find out my tutor? Because it's my first.
Oh, your tutor.
Yes.
Oh, you don't know your tutor.
No.
Okay, so Khotso, can you please just write down your email address so that they all can write it down?
Sorry, Prof. I have.
Yeah, and
Hello,
then they
Prof.
can write it down, and all these
Sorry, I
questions they
have
can email
network
you.
issues.
Yeah, I think Umpila Salai is in one of the groups. I remember that name, and then the name of the tutor is there, but they can you can address that question to Khotso, who is handling all that. But if you got his email address, then you can address it to him. So that is why I'm saying, Khotso, if you put down your email address and give it to everybody, then they can address all these questions to you at any time they want to. Okay.
Thank you.
All right. I can just help you along. Let me just one moment. One moment. Right. Khotso's email address is, I'm not writing it down, it's KGOTSO KGOTSO at, then it's South African Maths Foundation, SAMF samf.ac.za. It's .ac.za. It's kgotso@samf.ac.za. Please write to him any questions about linkages and assignments and so on. Then he'll help you along. Okay. Okay. Are there any other questions? All right. If there are no other questions, thank you very much, and enjoy the rest of the day. Hopefully, you will hand in your assignment within the time period. I think you said up to Monday. You've got a chance from now till next week, so you can work on the assignment and send it in, and it will be marked and sent back to you. Thank you very much. We can now leave.